fundamental interactions. In the nature, there are numerous forces acting each other between objects, living, non-living, or whatever be it. All these forces can be classified into four. One is gravitational, electromagnetic, strong and weak. According to the strength of the force, you can tell gravitational as the weakest. Then comes the weak force, stronger as compared with the gravitational. Then electromagnetic, and strong is the strongest force. The gravitational force is the rule of the universe. Planetary motions, movement of the galaxies, speed of satellites, everything can be explained on the basis of gravitational force. Whereas electromagnetic force is the rule of earth, or you can say nature, where most of the phenomena happening in the nature can be explained with the help of electromagnetic force. Whereas strong and weak forces are the forces acting in a nucleus. Strong force is very short range, and weak force accounts for the decay of the nucleus. Now, if you take the gravitational force, we have a very simple relation which is known as the inverse square law. The force is equal to gm by r square, where m and m are the masses of the force bodies, and r is the distance between the objects. Here we can see that the g, the gravitational constant, is too small, that's 6.67 10 to the power minus 7. Therefore, the gravitational force has some meaning when the masses are considerably large. As an example of gravitational force which can be observed in the nature, as we can take it as the neap tide and the spring tide happening according to the alignment of sun, earth and moon. When sun, earth and moon are in a longitudinal way, we have spring tide, or what we call the high tide, along the equatorial line of the earth. Whereas if the moon is transverse with respect to the position of sun and earth, there will be neap tide. Coming to the second one, that is electromagnetic force. Electromagnetic force, as the name implies, electric force accounts for the interaction between charges, and magnetic force accounts for the interaction between magnetic objects. But altogether, being two sides of a coin, electric and magnetic forces can be explained as a couple of electric field and a magnetic field, which is governed by the law called Lorentz force law. Now, if you look around, almost all phenomena happening around us, right from the lightning, a butterfly, wings of a butterfly, the colors of flowers, the beating of heart, and even a drop of water at the tip of the finger can be explained on the basis of electromagnetic force. That's why we say electromagnetic force rules the nature. Whereas coming to the strong force, as the name implies, it is a force which acts inside the nucleus to bind the nucleons to a very small volume, and it is governed by a potential relation U of r equal to minus u0 r0 by r e to the power minus r by r0, known as the Yukawa potential energy. And the strong force accounts for the interaction between nucleons, means protons, neutrons inside a nucleus. Now, coming to the weak interaction accounts the decay of the nucleus. Even if the nucleus is so strongly bound, it decays. Some particles comes out of the nucleus, surmounting the strong attractive force. So that accounts by the weak interaction between the nucleons. Now, when you say interaction, this happens, see, if a person wants to push someone else, he can use his hand, or he can pull with his hand. Whereas two particles, how do they exchange force between each other? This is explained by the fundamental force which results from the continuous exchange of particles between two bodies. As the figure shows, the first one shows exchange of particles causing attraction. A lady and a gentleman throws boomerang which comes the other way to make them attractive. Whereas in the second one, the repulsive force acts when a heavy ball is thrown to the other one, keeping them repulsion. So these gentlemen can be accounted like like charges, and the lady and the man can be accounted like unlike charges causing attraction each other. Now, what is the strength, range, and direction of fundamental forces? Momentum of exchanged particle determines the strength of the force. Mass of the exchanged particle determines the range of the force, and the nature of the force, whether it should be attractive or repulsive, depends on the direction of the momentum exchanged. If we take gravity, we assume that there are particles which are very light or mass nearly equal to zero, called gravitons, even if they are not physically observed. Then we have weak force, we have electromagnetic force and strong force with their respective exchange particles. Weak force, we have exchange particles, W bosons and Z bosons having mass greater than 80 GeV. And electromagnetic force, again, photons are being exchanged with mass nearly zero. And strong force is accounted by the exchange of mesons or gluons, mass greater than 0.1 GeV. So we can see that if the mass is zero, the range is very large, and if the mass is considerable, the range is very short. Now, to summing up, we have four forces: gravitational, weak, electromagnetic, and strong. The last column you can see magnitude of the forces. If you take gravity as a unity of a unit force, we can see that weak force is 10 to the power 26, electromagnetic is 10 to the power 37, and strong force is 10 to the power 39. So widely ranged magnitude of force. Now gravity acts between all particles, whatever be the nature of them, with certain mass. Whereas weak force acts between quarks and leptons, electromagnetic force acts between charges, strong force acts between quarks and gluons. And as you know, gravity or gravitational force is always attractive, and the range is infinity. Weak force is again attractive and the short range. Electromagnetic force again in finite range because of the photon, and strong force is accounted by gluons, which are heavy and short range. Thank you very much.